Putting numbers into perspective, proportions and percentages. A proportion is an equation that states that two ratios are equal. To solve or check to see if we have a proportion, we cross multiply. Let's take a look at a short example of how we will use proportions to solve contextual problems in this class. If 2 tires cost $75, how much will 4 tires cost? When we use proportions, it is important that each ratio be set up in the exact same manner. In this example, the first ratio we see is that 2 tires cost $75. It is imperative that the corresponding ratio on the right-hand side also feature the quantity of tires in the numerator and the cost in the denominator. Since we don't know the cost, we'll leave it blank as a question mark or use a variable to represent our unknown. Cross multiply to set up a simple one-step equation in order to continue solving. After cross multiplying, we're left with 300 is equal to 2n, the unknown. In order to solve this simple one-step equation, always divide by the coefficient or the number in front of the variable, or your unknown quantity. In this case, we would divide both sides by 2. Always remember to give a short description of the numerical value you found. There are multiple units in this problem. We need to be clear whether or not the 150 refers to the total cost or the total number of tires. Within the steps of cross multiplication, it is not necessary to keep the units, but we always need to remember that we were originally seeking the cost of those 4 tires. So the 4 tires will cost you $150. Let's take a look at another example. Barbie's average height is 12 inches with a 3.75 inch waist. The average woman is 64 inches tall. If the average woman was proportional to Barbie, what would her waist size be? We set up our proportion as follows. Cross multiply in order to set up our simple one-step equation. Divide through by the coefficient or the number in front. We see that the unknown is 20. Remember what that unknown was referring to? It was referring to the woman's waist size. If the average woman was in fact proportional to Barbie, she would have a 20-inch waist. A percentage is a number or ratio expressed as a fraction of 100. It is denoted using the percent symbol. There are many ways to solve application problems involving percentages. However, I find it best to always use the proportion method we outlined in previous slides. We will always use the right-hand side of our proportion to represent the percentage in our problem as a fraction over 100. Percent is just a fancy way of saying divide by 100. We will then use the same method of cross multiplication to solve these types of problems. Let's take a look at a few examples to see how we're going to see percentages in this course. Dowdy purchases a shirt with a labeled pre-tax price of $21. The local sales tax rate is 6% in your state. What is the final cost, including tax, of the shirt? We will set up the proportion in the following way. Total price over labeled price is equal to our percent number over 100. Fill in the quantities that we know. We don't know the total price, but we know that since sales tax is added to the overall price of the item, the final cost to Dowdy is going to be 106% of the labeled price. 100% would represent the labeled price. The additional 6% would be the sales tax. Cross multiply in order to set up your simple one-step equation. Divide through by the coefficient or the number in front of the variable, and remember what we solved for. The final price of the shirt would be $22.26. This is not the only route that we can take in order to solve this problem. We could set up the proportion the following way. Tax over the labeled price equal to our percent number over 100. In this case, we're going to find the taxed amount first before then adding it back to the labeled price to find our total cost. The tax represented as a percentage would be 6%. Cross multiply in order to set up our simple one-step equation, and divide through by the number of the coefficient in front of n. Always remember what we solved for. In this case, $1.26 represents the taxed amount. Remember, in order to find the total cost of the item, we need to take into account the labeled price as well as the tax. We arrive at the same solution. The final price of the shirt would be $22.26. Percentages are often used to describe how quantities change with time. We can express change in two basic ways: absolute change and relative change. The absolute change describes the actual increase or decrease from a reference value to a new value. The absolute change will always have a specific unit attached to it, such as feet, inches, population, square miles, etc. It can be calculated by taking the new value and subtracting the reference value. The relative change is a fraction that describes the size of the absolute change in comparison to the reference value. Relative change will always be represented as a percentage. You may have heard relative change be described before as percent increase or percent decrease. In general, calculating the absolute or relative change always involves two numbers: a starting number or reference value and a new value. Once we identify these two values, we can calculate the absolute and relative change over a period of time. Note that the absolute and relative changes are positive if the new value is greater than the reference value and negative if the new value is less than the reference value. Let's walk through an example together and identify the absolute change and relative change. The population of a town was 10,000 in the 1980 census and 15,000 in the 2010 census. Find the absolute and relative change in population between the census dates. The absolute change is the actual change in population between the census dates. 1980 would be our reference value, 2010 would be the new value. So 15,000 minus 10,000 would leave me a difference of 5,000. We say that the population increased by 5,000 people from 1980 to 2010. The relative change is the percentage change in the population between the census dates. It can be found by plugging into the formula. We can conclude that the population increased by 50% from 1980 to 2010. Let's take a look at another example. Juan bought a computer 3 years ago for $1,000. Today, it is worth only $300. Describe the absolute and relative change in the computer's value. Pause the video here and try to answer the question before moving to the solution on the next slide. The absolute change is the actual change in value of the computer now as opposed to 3 years ago. The reference value would be the original purchase price of $1,000. The new value would be $300. The difference being negative $700. We can conclude the computer has decreased in value by $700 since the time of purchase. The relative change is the percentage change in value of the computer now as opposed to 3 years ago. It can be found by plugging into the formula. We can conclude the computer has decreased in value by 70% since the time of purchase. Because percentages can be subtle, many people misuse them, sometimes inadvertently and sometimes deliberately. Be aware of the following abuses of percentages. Beware of shifting reference values. Let's take a look at an example. Because of losses experienced by your employer, you agreed to accept a temporary 10% pay cut with the promise that he will give you a 10% pay raise after 6 months. Will that pay raise restore you to your original salary? We can answer this question by selecting an arbitrary number for your original salary. Let's use $100 to make things easy. Cross multiply to set up our simple one-step equation, and divide through by the number or the coefficient in front of the unknown. We see you agree to take a temporary $10 pay cut in the beginning. Next, let's see what happens 6 months down the road when you are to receive your pay raise. Notice that your pay raise is going to be based upon your current salary. What is your current salary? If you took a $10 pay cut, your new current salary would be $90. Cross multiply to set up our simple one-step equation. Divide through by the number of the coefficient in front, and we will see you receive a $9 pay raise after that 6-month time frame. After the pay raise 6 months from now, you are only earning $99, not the original $100. We often see numbers that represent large more than percentages. For example, a price of $40 is 30% more than the price of $10. However, in most cases, it is impossible to have less than percentages that are greater than 100%. Take a look at the following example. A store advertises that it will take 150% off the price of all merchandise. What should happen if you go to the checkout counter to buy a $500 item? Does it make sense that you expect to save $750? No, that doesn't make sense. More than likely the manager made a mistake. As a general rule, we should never average percentages. Take a look at the following example. Suppose you got a score of 70% on the midterm exam and 90% of the questions correct on the final exam. Can we conclude that you answered 80% of the questions correctly? It might be tempting to say yes, after all, 80% is the average of 70 and 90, but it would be wrong unless both exams had the same number of questions. Consider the following. Let's suppose the midterm had 10 questions and the final had 100 questions. A 70% on the midterm means that you answered 7 questions correctly. 90% on the final means that we answered 90 questions correct. In total, then, we answered 97 questions correct out of a possible 110. Setting up our proportion, we see that on the 2 exams combined, you scored 88.2%, much higher than the 80% average of the 2 individual exam percentages. Again, be careful. As a general rule, you should never average percentages.